Hello everyone. So in this video we are going to see second practical of CAE, that is a stress analysis using 1D element. Okay. So question is description. A stress model consists of 3 bar. So first, second, third. So 3 bars is there, and the diameter of that bar is 20 mm. So cross section of this bar is a circular one, loaded by the load of 10 kilonewton as shown in figure. So this 10 kilonewton is in downward direction. Consider the material of the truss as a structural steel and determine direct stress, maximum stress, minimum stress, and the reaction at the support. Okay. So first of all, the dimensions of the stress is given here. If you can see, for on this point it is fixed, at this point it is also fixed, and at the third point here the force is applied. Dimension is given 2 meter 2 meter. Okay. So we have to find out these solutions with the help of ANSYS software. So this is ANSYS workbench we are going to use. First of all, click on or drop this structural steel in projects schematic. Okay. And first one, you have to give the name, that is stress for the project. Now double click on this engineering data. Here you have to select the material which you have to select. The material is to be select, that is the structural steel. Now by default the structural steel is selected. Now if you want to change the material, you can insert new material layer, give the properties of the material, that is Young modulus, Poisson's ratio, density. Okay. So this value is to be known for that material. Also you can see select the any material. So standard material is already available, you can select from here also. Okay. So here the material will be remain as default. Next, go to the geometry, double click on it. It will take a specific time to open. So this is a modeling window where you have to create the model of the stress. Okay. So first of all, click on XY plane, right click. So we are going to select the XY plane for creating the model. Go to sketch. Okay. So first of all, you have to create this truss model. Okay. For that, select the line from this draw, click on one point, again click on another point. Okay. Again I'll click on origin, I will draw horizontal line and I will join this both the point. Now see, directly I have done, I have not given proper dimensions for that. Okay. For giving dimensions, click on dimension section, click on general, select the horizontal and vertical lines. Okay. So dimensions is appeared here, h1 and v1. Okay. If I want to edit this h1, okay, just click here. This yellow part is, you can see, so that not even these dimensions can be changed from this. So dimension is 2 meter, again 2 meter for vertical. Okay. So you can see what are objects that we have created. Dimensions can be also change from units. If you want meter, centimeter, millimeter. Okay. So you can select that. Next, go to modeling. As we have created the truss, next is select the concept. Go to concept from menu bar. Select line from sketch. Okay. You have to select the lines from sketch. This is a sketch that we have to select. apply. Okay, then generate, again concept, go to the cross section. Here we have to select the circular cross section. Okay, circular cross section of truss. So click on circular. Now we have to give the radius. See, radius you have to give. If you see numerical, diameter is given, that is 20 mm, and we have to give the radius, that is convert this diameter to radius first of all, and a unit which is, that is in meter. So the radius will be 0.01. So by default 0.01 is there. Okay, next click on this plus sign. You will see this on the part, that is line body. So click on line body. Okay, after that here cross section, it is not selected. So if you drop down, you will see the circular one. So select that and generate. Okay, so in this way we have created a model. Minimize this part. You will see the geometry is created. Next, go to the model, double click on it. Again it will take a specific time to open. Now this time is depend on the configuration of your PC. The high configuration, and within less time the window will be appeared. So here you can see the model what we have created, it is appeared here. Next step is meshing. Meshing is nothing but you have to create the object, you have to convert into number of parts, that is elements and node formation. You can also say discretization. So right click on mesh, generate mesh. Now see the meshing has been done. You can also change the element size. Right click, insert, sizing, select the object. So I will select whole object, apply. So element size here I will consider 50. Now element size can be depend as per your uh, configuration. Now see I have selected 50 mm. You can also select 60, 70. You can also select 20, 10, 1 mm. Okay, element size. But lower the size means smaller the size you are selecting, that much time will be required for solving the solution. Okay, and accuracy will be also increase. Generate mesh. Now see small elements are there. Okay, next step is to give the boundary condition. For giving the boundary condition, just right click on static structure. You have to insert fixed support. Two fixed support and one forces is applied. If you see here, okay, if you see in drawing here, in this vertex it is fixed, second vertex here both are fixed, and here at this vertex the force is applied in downward direction, that is 10 kilonewton. Okay, so same boundary conditions we have to apply. So right click on static structure, insert fixed support. Okay, so fixed, I will select the vertex from the menu. So this vertex I will select, applied. Okay, so upper vertex, upper point is fixed. Again I will click on static structure, insert fixed support. I will select second vertex. Okay, apply. Now on this third vertex I have to give the force. So insert force. Okay, select the vertex. Now see here, first of all apply. Okay, so you have to apply on this point. So vertex is selected. Next defined by, instead of this vector you have to select a component. On that component only we have to act the force. So we have to act force in vertical downward direction. So vertical direction is nothing but a y. If you see here, so vertical direction is nothing but a y. Upward is positive and downward will be negative. So here in y direction the force is 10,000. If I will just enter it, you will see the force is in upward direction. Now what we require, to force in downward direction. So for that, just uh, insert negative sign in front of 10,000, so automatically direction will be changed. Okay, so boundary conditions are already applied, that is a b part. So a point and b point is fixed, and c point where the force is out applied 10,000 Newton in downward direction. Now what we require, the solution. In solution, that is we have to insert total deformation. Right click, insert. You have to insert this beam tool. Okay, just select the beam tool, right click, solve. Okay, so can see the total deformation. So maximum deformation, here you can see the simulation. The maximum deformation is 1.2. You can select the probe. Maximum is where the force is applied, okay, and minimum where it is fixed. Okay, again you can see the total deformation at the any point with the help of this probe selection. If you want to see the at the center what deformation is there, that can also be seen. Similarly, beam tool, here you can see the direct stresses where the maximum stresses is applied. So in the region here the maximum stresses is applied, that is 45.046 megapascal unit is also given. Minimum combined stress, maximum combined stress, so all the values which is required can be seen. Okay, so I hope you understood this practical. Thank you, thanks for watching.